Today we're going to be learning about power to a power and product to a power. So raising a power to a power for any non-zero number a, integers m and n, a to the mth power raised to the nth power equals a to the m times n power. Raising a product to a power for any non-zero number a and b and an integer n, the quantity of a times b to the nth power equals a to the nth power times by b to the nth power. So let's look at simplifying these expressions using those two rules. So d to the third raised to the fifth power is really d to the third times by 5. So this is d to the 15th power. Here it turns d squared to the fifth power is really d to the 2 times 5. D to the third power to the 0 power is d to the 3 times 0. So this is d to the 10th power, d to the 0, and d to the 0 is 1. So our final simplified expression is d to the 10th power. Here we have x to the third raised to the negative 1, so we're going to multiply 3 times negative 1. X squared raised to the fifth power is 2 times 5. So we have x to the negative 3 times by x to the 10th. So then from here, we can add our exponents because we have like bases. So negative 3 plus 10 is 7. Here we're going to use the product to a power. So this negative 3. So we're going to have 2 to the negative third power, x to the fourth power, times by a negative 3. So 2 to the negative third power times by x to the negative 12th. And so we can simplify this without having negative exponents. We're going to have 1 divided by 2 to the positive third exponent times by x to a positive 12 exponent. Once again, we have a power of 3 to this product, so it's 2 to the third power times by x to the third power times by y to the third power, and then we still have our x squared. So we have like bases, x and x, so if we have x to the third times by x squared, we add our exponents. So we have x to the fifth power, y to the third, and lastly, 2 to the third power equals 8, so it's 8x to the fifth times y to the third. Here we have an exponent of negative 5 to this product, so it's 2 to the negative fifth power times by a to the second power raised to the fifth means we're multiplying by negative 5. C to the fourth raised to a negative fifth means we're multiplying by that negative 5. Here we have 6 raised to this product, so c to the negative first times by 6, and a to the 7th times by 6. So if we simplify, we still have 2 to the negative 5th. This turns into a to the negative 10th power, c to the negative 20 power, c to the negative 6th, and a to the 42nd power. So we have like bases. We have like base of a, so a to the negative 10th times by a to the 42nd. Negative 10 plus 42 means we have a to the positive 32 exponent. Another like base is our c's. So c to the negative 20th times by c to the negative 6th. Negative 20 plus negative 6 is a negative 26. So to get rid of our negative exponents, a to the 32nd stays in our numerator, 2 to the 5th, and c to the 26th in our denominator. So the last thing we need to do to simplify is 2 to the 5th power, which is 32, c to the 26. Here we have 4 squared. 4 squared is 16. And then we have a power to a product. So this is going to turn into 2 to the third power, x to the third power. 2 to the third power is 8. So lastly we need to do is 16 times 8, which is 128, x to the third. Here we have negative 3x raised to the second power, so we have negative 3 squared times by x squared. plus 2x squared. So negative 3 squared is 9, x squared plus 2x. So now we have like terms, so we can combine our like terms. So we have 9x squared plus 2x squared, which equals 11x squared. Here we have scientific notation, but it's raised to the second power. So we have 6 squared times by 10 to the 12 times by 2. 6 squared is 36 times by 10 to the 24th power. We need to make sure this is in scientific notation. So right now we have 36, so our decimal needs to be between 3 and 6. So 3 and 6/10 times by 10 to the 25th power. Here we want to rewrite each expression with only one exponent. So here we are sharing the exponent of 4. So that means we have the product of m times n raised to the 4th power. 49 can be rewritten as 7 squared, x squared, y squared, z squared. So that means we have the product of 7 times x times y times z, all raised to the 2nd power. Here I know 12 divided by 3 is 4, so I have 4x squared divided by y squared. So I also know that 4 can be rewritten as 2 squared. So that means we have the product of 2 times x divided by y raised to the 2nd power. Let's complete each equation. So x squared to some power will equal x to the 6th. So that means it has to be a 3 because 3 times 2 is 6. B squared raised to some power will equal b to the 8th. So that means it needs to be 4 because 2 times 4 will equal 8. Here if we have n to the 9th times raised to 1 a power equals 1. So it's going to be a 0. Five times x to some power and then squared will equal 25x to the negative 2. So this will need to be a negative 1 because negative 1 times 2 is a negative 2. And here, in order for these to end up in the denominator, that means they had to have been negative. So to get a negative 6, you multiply both by 3. 2 times negative 3 is a negative 6. Make it into a positive. Put in the denominator. 3 times negative 3 is a negative 9. To make in the denominator needs to be a positive.